So looking at this example here, question 18, we want to factor a polynomial. Notice how the variable is actually z, so watch out for that in MyLab. If they change the variable from x to z or whatever letter, sometimes they like to use t's as well, or y's. So pay attention to the variable to begin with. Now remember, if you're factoring a trinomial, you have this checklist over here. Again, this is printable. So again, you're always looking for a GCF to start with. So if I look at these three terms, the only factors of the first term are a 5 and 2 z's. I don't see, there's a z in common here, but I don't see a 5 in common. And on the last term, I don't see a 5 or a z in common with that. So there's no common factor that we can actually pull out. To be a difference of squares, it's got to be a binomial with the subtraction sign between it. Well, this is a trinomial, so that's out. To be a perfect square trinomial, the first term has to be a perfect square. Notice that the 5 nor the 8 are perfect squares. There's not an actual whole number that you could square to get a 5 or an 8, so that's out. So the next thing we look at is, since this is a second degree trinomial, like I said, the 2 there tells me it's a second degree trinomial. And remember, this is the quadratic term. The 5z squared is the quadratic term. The 13z is the linear term, and the 8 is the constant. The 5 is also called the leading coefficient in this problem since it's out front. So one of the strategies is just guess and check. If you just recognize that it's got to be a binomial, so we have, let's see if I can get this to work here. Hold on a second. So let's see if I can get this working again. So if I want to try to factor this trinomial, remember it's going to be a binomial times a binomial. If you're using FOIL as a thought process, the first term, the 5c squared, goes in the first two positions. Notice that there's only one way to really break that apart, and that's a 5z and a z. Now, it doesn't matter where they go. They can just go into one of those spots here. Let me bring this down a little bit. Give myself a little bit more room. So, see my two sets of parentheses here. So the 5z and the z can go here. Now, the factors of 8, though, notice that we have a 1 and an 8 and a 2 and a 4. So notice how there's not that many possibilities for the 8 either. That's it, because the next thing we have, 3 is not a factor, but 4 times 2 is a factor, but that's just repeating. So really, there's not that many choices here if I was trying to do some guessing and checking. Now, to get this 13z, it kind of seems like what I need is, this 8 and this 5 really they're jumping out at me a little bit, because 8 and 5 is like a 13. So, but I can't put the 8 over here on this side, because if I put the 8 and 1 over here, remember, you're going to be doing the outer terms, and that's going to give me like a 40z, and an inner term is going to give me a 1z. That's going to be 41z. But if I move this around and put the 8 here and the 1 here, when I do the outer, notice how that's 5z, and when I do the inner, that's an 8z, and 5z and 8z does give me this 13z. So notice how they both have to be positive. So the factorization would be 5z plus 8 times z plus 1. So since there's not a whole lot of possibilities, you could probably just kind of guess and check it. Now, if you want structure, if I want to factor a second degree trinomial in the form of ax squared plus bx plus c, in other words, there's now a leading coefficient that's not 1. If it's 1, then you just kind of use this strategy. But since we have a 5 here, this kind of falls into this strategy. So if you need a structure, you can use 4 square and dig t. So what I can do is draw my 4 square. Maybe just use a different color here, so it kind of stands out a little bit. So when you use 4 square, the quadratic term, the 5z squared, will go in the top left. The constant, the 8, goes in the bottom right. Now, when we use big T, we have to multiply the A times the C. In other words, we have to multiply the 8 times the 5 together. So 8 times 5 is going to give me this 40. So what I'm looking for, if I'm using this big T, are the factors of 40 that add up to a 30. So again, the factors of 40 would be 1 times 40, 2 times 20, 3 is not going to work, 4 times 10, 5 is going to work as well, 5 times 8, 6 is not a factor of 40, 7 is not a factor of 40, 8 times 5 is, and that's just repeating. So notice that, to get this 13, what's jumping out at me is actually this 8 and 5. So 5 times 8 is 40, and 5 plus 8 is 13. So what happens is, using 4 square, the 5 and the 8 become the coefficients of my linear term. So remember, my linear term is this z. So this becomes then this 5z, and then this 8z goes here. Now, the way the 4 square works out is you now have to factor out the common factor between the 5z squared and the 5z. So what we're looking for is they both have a 5 in common, they both have a z in common. So what I'm picking up on then is there's going to be a 5z out here. So then what I got to ask myself is, what times 5z is 5z squared? Well, I would need a z. 5z times z would be 5z squared. And then what times 5z is 5z? That would have to be a 1. And then we move down to this spot. What times z is 8z? Well, that had to be an 8. 8 times z is 8z. And does 8 times 1 give me 8? And it does. So notice how the outside edges are actually the binomial times the binomial. So notice how this will give us then this 5z plus 8 times then this z plus 1. It would give me the same result with a little bit more structure, with a little bit less guessing and checking. So again, the key is to multiply the leading coefficient times the constant. So again, that's going to be our biggest strategy there if I'm using 4 square.